let's start now with class 3 for the IB Mathematics standard level. We'll start with an introduction to functions. We can start with the relation. The relation is any equation that has a mapping between values of x and the values of y. Let's say here we have values of x, say g, f, and e, which is x, and we have here values for y. This is y, say this is z, r, and k. If we map these values, let's say g for the x values maps to y, z for the y values, f maps to r, and e maps to k. These x values, we call them the domain, and the y values are the range. The elements in the domain, we call them elements of the domain. These are elements of the domain, and we call these values images in the range. So the image of the element g in the domain is z. This is for a relation. A relation can either be a function or not a function. For a relation to be a function, what's the definition of the function? The definition of the function is each element in the domain must have only one image in the range. Let's take an examples. Let's say the relation number 1, if I have e and k with g and r. E maps to g and k maps to r. Is this a function or not? Yes, it's a function, because each element in domain has only one image in the range. Let's say, take example 2. If we have E, K, R, and we have G with Z. E maps to G and K maps to Z. Is this a function or not? It's not a function, because the element R has no image in the range. Another example. If we have E, K, and we have Z, R, and G, E maps to Z and to R, and K maps to G. Is this a function? No, it's not a function, because the element E has two images in the range. So we don't consider this relation as a function. More examples. If I have this common example, let's say I have ER and I have G, K, and Z. E maps to G and the element R maps to the image K. Is this a function? Many of you will say it's not a function because the Z has no element in the domain, but it's a function, because in order to be a function, we've said that each element in the domain has only one image in the range. If this was satisfied, then it's a function. I don't care about the Z. I only care that the E has only one image, the R has only one image. All the elements in the domain has images. I don't care the image Z if it has an element on the domain or not. So this is considered to be a function. We can continue now. Example 5, if I have this case. If I have G, R, K, Z, and I having here E and L. G maps to E, R maps to E, K maps to L, and Z maps to L. Is this a function? Yes, it is a function. But here we have that one image has two elements in the domain, it's fine. Since I'm having each element in the domain has only one image in the range, it is a function, but we call this function as many to one function. And our previous functions, this is called one-to-one function. This one also is a one-to-one function. So now, after knowing this, if a relation is the function, then it's either be a one-to-one or many-to-one function. Now, let's test it graphically. We have to test it graphically. Let's see this example. Example 1. Having coordinate axis. I'm having a function. This is straight line. To test it graphically, we have two tests. The first test is the vertical line test. This test if a relation is a function or not. If the relation is a function or not. After knowing if it's a function, we have a horizontal line test. It tests if a function is many-to-one or one-to-one. So let's see this function. We will draw a vertical line. As we can see, it crosses here in one point. Another vertical line, it crosses at one point. If the vertical line test crosses only at one point the curve at any place, then we consider it as a function. Now we knew if it's a function or not. Then we have to know that this function, is it one-to-one or many-to-one? We make the horizontal line test. The horizontal line test at any place crosses only in one point. So after using the horizontal line test, this is the vertical line, this is the horizontal line test. The horizontal line test crosses in one point, so this function is considered to be, this function is considered to be a one-to-one function. We can take more examples. This example. Let's test if it's a function or not. We draw a vertical line, crosses in one point, and here it crosses in one point. So this relation is a function. Let's see if this function is one-to-one or many-to-one. We draw a horizontal line test. The horizontal line test crosses the curve in 2 points. So this function is a many-to-one function. Another example. If we have this one. Is this relation a function? We draw a vertical line test, and we can see that the vertical line test crosses in 2 points, which means that this x value has 2 values in the range. So this is not a function. It is a relation. This relation is not a function. This relation is not a function. After knowing that the relation is not a function, is a function or not a function, and after knowing the function, if it's many-to-one and or one-to-one, we can go to function notation and composite functions. So for function notation, it's simply f of x equals x squared plus 4. This is what's meant by function notation. I assume a function as f of x equals x squared plus 4. This is the function notation, or whatever I can say it's an r of x is equal to x plus 2. This is a function. Let's have another function so we can take an example directly in composite function. If it's g of x is equal to x plus 4. And I wanted to know part A, I want to know f of 1. F of 1, simply I substitute 1 instead of x, it's equal to 1 squared plus 4, which is equal to 5. This is f of 1. If I want to find the values of x for which g of x is equal to 3, simply to solve this, I take g of x, which is x plus 4, put it equal to 3. So x is equal to -1. For composite functions, let's say I want f of g of 1. This is a function for g of 1 inside the f of x. So the first step, I need to find the g of 1. G of 1 is equal to what? 1 plus 4, which is equal to 5. So now I need to find the f of 5, since g of 1 is equal to 5. F of 5 is equal to 5 squared plus 4, which is equal to 29. If I want to find the composite function f of g of x, f of g of x, f of g of x is equal to, I put the g of x, simply I take the g of x, which is x plus 4, and I plug it in inside the x of the function f of x. So it becomes x plus 4, all of it, squared plus 4 outside, which is equal to x squared plus 8x plus 16 plus 4, which is equal to x squared plus 8x plus 20. This is for the composite functions. And we've talking about the domain and range of a function. The domain means all the x values, and the range of a function are all the y values, and it's essential to know it because many questions ask about the domain and the range. Now we can go to the inverse function. The inverse function. The inverse function, we write it, if I have a function f of x, then the inverse of f of x is f inverse of x. Meaning, if I have a domain and a range, this is my domain and this is my range, f inverse of x, it means I'm changing between the domain and the range. So the range becomes as the elements of the domain, and the range becomes as the element of domain, and the domain as the elements of the range. So simply the range, let's say starting by the domain of f inverse of x is equal to the range of f of x, and vice versa. Which is simply we are changing the x by the y. Let's have an example to find the inverse. If example, if f of x is equal to 3x plus 4, we need to find f inverse of x. F of x equals 3x plus 4, we can write it as y is equal to 3x plus 4. Now, in the inverse, we've said that we change the domain by the range, which means I change the y with the x. I change the y with the x. So it becomes x is equal 3y plus 4. And now simply I make the y subject. So now y is equal x minus 4 over 3, which is the inverse function of f of x. So now I can write f inverse of x as x minus 4 over 3. This is my inverse function. Now we've covered what's meant by a domain, which are the x values of a function, the range, which are the y values, and a mapping between x and y makes me a relation. This relation is either be a function or not. If it's a function, we have two types for a function: the one-to-one function and the many-to-one function. To test for a function, we use the vertical line test. To test if a function is many-to-one or one-to-one, we use the horizontal line test. After using this, we've got into the function notation, how to solve composite functions, and finally the inverse function. One more thing we have to know about the inverse function. Now, the inverse function is the reflection on y equals x. Let's say if I have a function which is 3x plus 4, let's draw f of x. This is f of x. If I want to sketch the f inverse of x, simply I reflect f of x on the line y equals x, on this line. this line is y equals x, I reflect the function f of x on this line. Need to draw another line, which is a reflection. It's something like this. The line in blue is the inverse function of x. I hope it's clear enough. Now we can go and solve a question from the question bank. The question says the following diagram shows the graph of the function f with the domain x is from -2 to 4. We can see that the domain, which are the x values, from -2 to 4 for this function. The points -2 and 0, and 4 with 7, this is 4 with 7, lies on the graph. Write down the range of f. The range of f, it means we need all the y values. So the range, the y values, the minimum y value as we can see here is 0, and the maximum y value is 7. So we can say that the range is f of x such that f of x lies between 0 and 7. 0 equal to f of x because 0 is included, and 7. This is my range. Part B, section I, we need to write down f of 2. F of 2, it means I want the value of the function when x is equal to 2. We can look at our graph. When x is equal to 2, what's the value of the function, which is the y value? When x is equal to 2 here, the y value is 3. So simply f of 2 is equal to 3. This is B section I. B section double I, we need to write down the value of f inverse of 2. F inverse of 2 means I want the value of x when y is equal to 2. Because it's f inverse, I change the x with the y. When y is equal to 2, here is my y. The x value is what? Is as 0. So now f inverse of 2 is equal to 0. Part C, on the grid, sketch the graph of f inverse of x. Let's just erase so we can sketch the graph of f inverse of x. I have to reflect on the line y equals x. This is the line y equals x. Y equals x. And our new function simply is a reflection. It will be something, and the -2 will be reflected here on the -2, and the 2 will be here and the 2. So it will be something like this. And it ends up here. This is the graph of f inverse of x. This is part C. A very good base in functions is really essential because functions are included in every topic coming in the mathematics standard level course.